You can be.
So today we discuss about what is data and how do we pre-process this data to apply some data mining algorithms. So first of all, we need to understand what is data. Data is a collection of data objects and attributes. If you see the right side, there is one data set is given here that has 10 objects and 4 attributes, including transaction ID. If you see, then it will become 5 attributes for each object you have. So what is attribute? An attribute is a property or characteristic of an object. So the first object, what is its marital status? It is a characteristic of the first object. So it is single. It may be denoting this data set, objects are some persons. So example, eye color of a person, temperature, etc. Attribute is also known as variable, field, characteristic, dimension, or feature. So people will use different terminology for these attributes. Some people may say features, some people may say attributes, variables, fields, or characteristics, or dimensions. So all these are used interchangeably in data mining. A collection of attributes describe an object. So if you give different properties, then those properties together become an object. Object is also known as record, point, case, sample, entity, or instance. All these words are used interchangeably to denote an object. When we have attribute, what values it can take? What is the meaning of attribute value? Attribute values are numbers or symbols assigned to an attribute for a particular object. If it is numbers, then we say numerical attribute. If it is not numbers, then we say categorical attribute most of the times. Distinction between attributes and attribute values. Same attribute can be mapped to different attribute values. For example, height can be measured in feet or meters. Different attributes can be mapped to the same set of values. Example, attribute values for ID and age are integers. But properties of attribute can be different than the properties of the values used to represent the attribute. Here we need to understand, same attribute, it may have different values. So here one example is given. If you take height, those values may be given in terms of feet, 6 feet height, 4 feet height, like that. Or it may also be said 1.5 meters, 1.2 meters, 1.1 meters height, like that. So same attribute may have different attribute values. Different attributes can be mapped to the same set of values. So here one example is given. If you take ID, that may be an integer. Similarly, age also may be an integer. So different attributes can take same attribute values. But properties of attributes can be different than the properties of the values used to represent the attribute. So the properties of attributes doesn't depend on what values it is taking. So what types of attributes we have? There are different types of attributes, mainly 4: nominal. Examples, ID numbers, eye color, zip codes. They are just some names. They don't have any much meaning more than that naming them. So we'll see that what is the difference in next slide. Then second type of attributes are ordinal. Examples, rankings. Example, taste of potato chips on a scale from 1 to 10. Grades, height, tall, medium, short. So it is nothing but ordinal means we can compare which is higher, which is lower. So if you can compare those values, then that attribute values, if they can be compared, then those attributes are called ordinal attributes. Interval, examples, calendar dates, temperatures in Celsius or Fahrenheit. In intervals, you can see exactly how big it is than the other attribute value. In ordinal, you may not say that. We'll see the examples. Exactly how much it is bigger than the previous one. Those things we cannot compare two attribute values to the extent of how much they differ. They differ in which direction? That only we can compare for ordinals. So intervals you can compare, and you can also say that how much they differ. Ratio, the last one. For ratios, examples are temperature and Kelvin, length, counts, elapsed time. You can also make in ratios, let's say what is 1/3, 1/4, 1/5 like that, which you cannot do in intervals. Only you can say that 1 less, 2 less, something like that. So if we come to the properties of attribute values, what properties these attributes will have for different types of attributes. So the type of an attribute depends on which of the following properties operations it possesses. So we define now 4 types of attributes. Now we are giving definition. If they follow these things, these properties or operations, then that attribute is called nominal or ordinal or intervals or ratios. So if you see a distinctness, nominal means you can say that this is not same as other value. That's all. You cannot make these two are equal. These two are something you can say this is less than that. All those things you cannot say. Suppose color. Color, if you say red, green, nobody can say that it's whether red is smaller than green or green is smaller than red. So it's only the first one, nominal, will allow us only to differentiate that cell, whether it is equal or not. Only one operation you can perform. These two attributes, attribute values for two different objects, whether they are same or not. The second property is order. Can you also say that which one comes first, which one comes later, or which one is smaller, which one is bigger, like that? That is one more operation if we can perform. Then it may become ordinal. Differences are meaningful. So if you can say that this is exactly 2 points more than that, or in a scale of that, it is off. In order, you cannot say that. You can only say that it is bigger or not, that's all, or it is smaller or not, along from whether it is equal or not. So when it comes to the differences are meaningful, you should be able to say that how much it differs. Then ratios, if ratios are also meaningful, it is 1/4, 1/3 like that, then it is the 4th one. So the first one, nominal, will be able to distinguish only distinguish the elements. When it is ordinal, it also distinguish which one is smaller, which one is bigger. When it comes to the intervals, the differences will be meaningful. When it comes to the ratios, ratios are also meaningful for that attribute values. So nominal attribute possess distinctness, so ordinal attribute distinctness and order, interval attribute distinctness, order and meaningful differences, ratio attribute all 4 properties of operations. So these are supersets. So ordinal attributes, whatever nominal attributes have properties plus extra. Similarly, the remaining things. So here a table is given to remember these things. Categorical, qualitative, the first 2 are. The second 2 are numeric, qualitative, interval and ratios. So only if it is numeric, then only you can say the differences are meaningful and ratios are meaningful. The first 2 are categorical. You can see that description. Nominal attribute values only distinguish. Then examples, zip codes, employee ID numbers, eye color, sex. You can say that there is nothing like male is bigger, female is smaller, female is bigger, male is smaller. You can say that they are not same, having same sex. Mode, the operations, what you can do is mode. You can see that which one is appearing more number of times, which one is the most frequent attribute value. Only you can do those things. entropy contingency. We will study its entropy contingency in coming modules. Correlation chi-square test. These you can do on nominal. When it comes to the ordinal, you can also say that compare them whether it is smaller or bigger. Ordinal attribute values also order objects, hardness of minerals, good, better, best. We cannot say that better is exactly 2 times of good. If you have those numbers, it becomes an interval. So here we can say that better means it is better than the good. Some best is the more sweeter, whatever that it's the hardness of minerals. It is above than better. Then grades A, B, C, D, street numbers. This third, fourth. So fourth will come after third, something like that. But you cannot say that exactly. It is distance is same between 3 and 4 and 4 and 5. 4 and 5 streets. Median, percentiles, rank, correlation, run test, sign test. These operations you can do. So you can say that you can find median. You can also find percentiles, rank, correlation, run tests, and sign tests also you can do. So coming to the numeric qualitative attributes, intervals. For interval attributes, differences between values are meaningful. You can also add them. You can also subtract one from others. Then calendar dates. So before 3 days, what is date? We can say. So there is a difference, 3 days differ, these 2 days, something like that. Calendar dates, temperature in Celsius or Fahrenheit, mean, standard deviation, Pearson's correlation, T and F test. These can be possible. These can be computed on intervals. So coming to the ratios, for ratio variables, both the differences and ratios are meaningful. The differences should be meaningful. Also, it should be, ratio also should be meaningful. Temperature and Kelvin, monetary quantities, counts, age, mass, length, current, all these things, let's say when you make a division, it is still has some meaning. In intervals, it may not have meaning, right? Something like, let's say, if you say, in sometimes it's say 3 people are there, you cannot say that it's say 1.5 people by 2, 1.5 people are present. So those things are not possible in intervals. Here, it should be possible when you divide by something, take a ratio, it should be still meaningful. So here you can find mathematically geometric mean for these ratios. You can also find harmonic mean. You can also find percent variation. The categorization of attributes is due to S.S. Stevens. So this Stevens has given this table. So again, I repeat, there are 4 types of attributes. The first one is nominal. Only you can distinguish whether they are same or not. The second one is ordinal. You can distinguish them and also you can compare them, which one is bigger, which one is smaller. The third one is interval. You can distinguish, you can compare, you can also find the differences between 2 values. Coming to the ratios, not only about 3, distinguish, compare, find differences, and you also have meaning for ratios here. There are 2 more distinct qualities of attributes apart from that types. So they are called discrete and continuous attributes. What is the discrete attribute means? It has only a finite or countably infinite set of values. Means you can count them. You should be able to say that what is next number, then what is next value above this or below this. If that is possible for a attribute, and then it is called discrete. Example, zip codes. So suppose Hyderabad, if you take 500001, what is the next zip code? Immediately people can say that 500002. So we know that what is next. Or we can count first one, second one, third one, like that. Or the set of words in a collection of documents. So they are again finite and you can put them at the first word, second word, like that. often represented as integer variables. Note, binary attributes are special case of discrete attributes. So you have only two values there, finite there. So infinite means all numbers which you can order them, or you can say that what is the next number in some order, then they are called discrete. All integers are discrete. What is next number after 4 and integers? 5. What is before 4? 3. So now we see what is continuous attribute. Has real numbers as attribute values. So most of the time continuous attributes means real numbers, the attribute values are real numbers. Examples, temperature, height, or weight. Practically real values can only be measured and represented using a finite number of digits. In computer, we know that it's each integer and float has a representation of 8 bits or 16 bits or 32 bits. So anyway, it's saying in 32 bits, how many integers you can represent, that is a finite. So in computer implementation, it is finite, but in reality, real numbers are infinite. How infinite real numbers? We cannot say what is next real number. So if we cannot find what is next number in attribute values, then that becomes a continuous attribute. So suppose if you take a weight, then weight, what is if somebody says that it's this attribute value as weight 3.5 kilograms, then what is the next weight? We cannot say that may be 3.51. If somebody says that 3.51 is the next weight, then immediately other person will say that 3.505 is next one after 3.5. So in real numbers, what happens? If you take any two real numbers, there are again infinitely many real numbers between them. So if you have infinite values between any two numbers, two values, then that attribute is called continuous attribute. Is it clear what is discrete and what is continuous? For discrete, you can say what is next number. For continuous attribute, you cannot say that what is next number because there are infinitely many numbers between whatever you say the next number, I can give you another infinite numbers between these two. Then that is called continuous attribute. So most of the times, discrete attributes are represented by integers. Continuous attributes are represented by real numbers. Then another difference between attributes is asymmetric attributes. Only presence, a non-zero attribute value is regarded as important. So we don't measure anything. We will say that whether it is there or not. In NLP or text processing algorithms, we will see that whether that word is present in a document or not. We don't see that any other thing. So the word if it is present, we'll write 1. If it is not present, we'll write 0 for that attribute values. So it becomes a binary. So asymmetric attributes means only presence is regarded as important. Items present in a customer transaction, whether an item is there or not. So why do we require this? If we met a friend in the grocery store, would we ever say the following? I see our purchases are very similar since we did not buy most of the same things. So when two people meet in a shop, they don't see that it's what didn't they purchase, because they didn't purchase the same items, they are similar. They look in the basket, what items are there, what you purchase, what I purchase. Okay, we both purchased similar items. So that's why our boxes are similar. That is what they say. So in asymmetric attributes, the presence is important, not the having those things in the basket. So if we get into the more categorization, we don't describe each and everything, but the terminology is important. The incomplete things are asymmetric binary, whether it is there or not, how many times it is there, how much a quantity is there, we are not interested. Only we are looking whether that item is there or not. Then cyclical, multivariate, partially ordered. You may not say that it's exactly it is, this is bigger or not, but you can put them in some order. Then partial membership, relationships between the data. These are some incomplete things. Real data is approximate and noisy. So most of the times, whatever we get the data, that is only approximated data or noisy data. This can complicate recognition of the proper attribute type. Treating one attribute type as another may be approximately correct. So these are the problems which we will get during the time of the collection of data. So we may not be able to measure accurately what is the value for that attribute. So we may get approximate values. Sometimes by erroneously, people may write something not accurate value, then it becomes a noisy value. Noisy means it is not accurate value, something it's by mistake it has come there. So any doubts regarding this discussion, data types? What is data and data types?